Notes, 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 notes. It's time to take your notes, 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 notes.
Haha, well, I hope you enjoyed that little tidbit of my awesome singing. But anyway, today we are rewriting radicals as exponents. So, exponents and radicals are definitely related. They're inverses of each other. So, what we can do is rewrite a radical as an exponent. But before we just know how exactly to do it, let's think about it a little bit. So we know that we want them to be inverses, like we just talked about. So what that means is that we want, if we take the square root of x squared, we want that to be x. That's the same thing if we do the square root of x and then we square it. It's the same thing, it's just in the opposite order. But we still want them to cancel out and give us just x. So then, if we want to rewrite the radical as an exponent, so say n, we're just making up a variable for that exponent because we don't know what it is just yet. So instead of doing the square root, we're going to say it's to the power of some exponent n. And same thing here, if we did the radical first, well, it would be x to some power, and then we square it. We want that to simplify to just x. So what kind of number could we have for n that would make that work? Well, scroll down a little bit. Basically, we know from the last unit that when we take a power to another power, what did you do with those exponents? We multiply them. So power to another power told us to multiply the exponents together. So what that means is if we take those two powers to each other, basically we would have 2 times n or n times 2, which would still be 2n. And we want that to simplify just to x, or x to the first power. So what that means is we want 2n, whatever that is, to be equal to 1. So what does that mean that n needs to be? Well, if we solve it, what would we get? We would have to divide by 2 on both sides, and then the 2's would cancel, and we would just have n equals 1/2. So that's what we want our exponent to be, 1/2. So basically what that means is that anytime we want to write a radical as an exponent, it's going to be a fraction, or it's going to be a rational number. Rational number means a fraction. So whatever number you have on the root is, that's the number that's going to go in the denominator of the fraction. Okay? And right now, this is just x to the first, so that's why the 1 is on the top. If it's a different number, that other number will go on the top of the fraction. So what we have here, for example, if I did the cube root of x, that would be x to the 1/3 power. Or if I did the 4th root of x, that would be x to the 1/4 power. Or the 5th root, x to the 1/5 power, you get the gist of it. Moving on down. What we can then do with that is, if we need to simplify, we can apply those same exponent rules to those expressions. So you might need to remind yourself of your exponent rules. You had multiplication rule, quotient rule, power to a power, and we had some stuff with negative and 0 exponents as well. Next page. All right, it's time to see some examples then. So we want to rewrite the following expressions as exponents. So all of these are radicals. We want to write them as exponents. So we have the square root of a. What's that going to be as an exponent? Well, if it's the square root, remember that's like a 2, so that's just going to be a to the 1/2 power. Same thing over here. If we have the cube root, that's going to be y to the 1/3 power. Now here, be careful, because if you can simplify, you want to try to do that. So we know the square root of 4, right? If we break this up using our multiplication property, we can do the square root of 4 and the square root of g, which we know would be 2, and then square root of g. And then we want to rewrite that as a exponent. So 2 and then g to the 1/2 power. Okay? All right, here. The 5th root of 2m. Well, none of those are going to simplify inside. The 2 doesn't, the m doesn't. So we're going to have to do the whole thing 2m. Since that's both underneath the radical, we need to put parentheses around it. And then to the 1/5 power. So notice, this has parentheses around it because the 2 and the m are underneath the radical. This did not because 2 was outside of the radical and the g was underneath. So only the g here gets the 1/2 power, not the 2. All right, the square root of x to the 3rd, well, that would just be x to the 3/2 power. Now, some of you might say, well, hey, we could simplify x to the 3rd and do the square root of x squared, square root of x, if we broke up the x to the 3rd into x squared and x, and then got x radical x. Well, what would happen if we did that? Well, that would be x to the 1st, and then times x to the 1/2 power. And then what do we do when we multiply terms together with exponents? So, since they have the same base, we would need to add those together. 1 plus 1/2 would be equal to 3/2. So we would get the same exponent either way. So we just need to do that. All right, cube root of z squared. So we're going to have z. Since it's squared underneath, we're going to have a 2 on the top. And a cube root means we're going to have a 3 on the bottom. All right, now we want to rewrite these radicals as exponents and then use our exponent rules to finish simplifying, kind of like we did up here in number 5. So with 7, I have the square root of x and the cube root of x. So if I rewrote those guys as exponents, the square root would be x to the 1/2, cube root would be x to the 1/3. Then if I want to simplify, I have the same base. What do I do when I multiply those together? I need to add the exponents. So I need to figure out what is 1/2 plus 1/3. So we reviewed fractions and adding and subtracting them in the beginning of the year. So hopefully you remember how to do that. Otherwise, you can try to use your calculator to help you. We need to get a common denominator. So our common denominator for this will be 6. 2 and 3 both go into 6. So I need to multiply by 3/3 to the 1/2 and 2/2 to the 1/3 to get those into 6s. So I have 3/6 plus 2/6, and then I add the tops together. 3 plus 2 is 5. So I have 5/6 for my exponent. So this is going to be equal to x to the 5/6 power. Okay. All right, we've got the square root of k to the 5th, and then the square root of k, that guy, to the 3rd power. So whatever the exponent is, that's going to be on the top of our fraction with our exponent, and then we need to take the root number on the bottom. So this first one here would be k to the 5/2, and then times k to the 3/2. Didn't write my 3 there. There we go. So we're multiplying these guys together. What do we do with the exponents? We should add. So 5/2 plus 3/2 is going to give us 8/2. And then what's 8/2? That's just 4. So really this whole thing is just k to the 4th power. Number 9, square root of g, so that's going to be g to the 1/2, divided by cube root of g, so that would be g to the 1/3. And then we are dividing these guys. So how do we write our exponents? So if we're dividing the terms, well, we need to subtract them first and then simplify. So we need to do this time 1/2 minus 1/3. And we already converted these into common denominators up here, so it's going to be the same thing, just now we're subtracting them. So 3/6 minus 2/6 leaves us with 1/6. So what we have here is g to the 1/6. Last one. Square root of p to the 7th, so that would be p to the 7 over 2. And then the square root of p to the 3rd would be p to the 3 over 2. And we're dividing again, so we need to subtract our exponents. So 7/2 minus 3/2 is going to leave us with 4/2. And then 4 over 2 is just 2, so this is p squared. Okay. All right, that should be it. Hopefully you picked up on that pretty well. If not, make sure you're asking for help. We love helping you guys, so just ask for it. All right, good work on your assignment and good luck.